Good evening. My name is Bashir Fancy. I'm one of the four-founders of BIZTEK Professional Association of Canada, BTPAC, which is part of ICCP. ICCP Institute for Certification of Computing Professionals is based out of Chicago. And in fact, 3 out of the 4 founding members are members of the board at ICCP, which has been around for a long time, does training, exam certification in many various areas of the technology. And I will provide a link so that you can look it up. We are now in Canada also and representing the organization. And we're hoping that people will take advantage, because not only is there training and certification, which is important, but we also work very hard on ensuring that people keep their knowledge and skills upgraded at all times. We all know things are changing drastically. And in fact, post-COVID-19 crisis, our world will be very different. So this is something we're hopeful that people will take advantage of. And of course, not only that, you will participate with us, either volunteering, getting involved in every possible way. We have ensured that there are no fees at the start, at least for the next 12 months. There are some nominal fees for, of course, the exams that you would sit for the certification, which you have to do every 3 years. But we are also there to ensure that you are spending the right professional hours. And there's a lot more. I will give you the link to the video. Tonight, I'm very pleased on behalf of my colleagues to welcome Hisham Qaddomi, who will speak on artificial intelligence in cybersecurity. Hisham's been doing programming since he was a young kid, and you will see as he speaks more about the challenges. And one of the couple of things that will come across to you when he does the presentation is, of course, the fact that artificial intelligence can be very powerful and helpful, but not managed correctly can also produce wrong results. So he's done an excellent job in the past, and I have no doubt he will do that today, here to talk about that. So I'm not going to take up much of your time, but do look up and participate with us. And let me hand it over to Hisham Qaddomi. Thank you very much. And it's over to you, Hisham. So as I said, we have Hisham Qaddomi here. And what we're going to do for us, he's got a tremendous background. I've been doing the programming since he was 10. And I've seen him many times. We've worked on certain things. A very capable guy. And he's also done TEDx, as you can see. So let me take you to part where Hisham can pick it up from here, and he'll talk about security design practices. Do you want to go from here then?
Yeah. So as you said, Bashir, this is a very tough time that we're passing. I mean, we already had a lot of challenges in cybersecurity, and right now within the COVID-19 and what is happening, the challenges are becoming much becoming more difficult. And the thing about it, about my job, is I worked in cybersecurity and AI, in those two worlds, and putting them together. And I think this is where the future is coming, specifically post this crisis and most of it. So we're starting by the current security practices. As many people might know, they're already working with NIST. Everybody knows what NIST is. Which is a framework practically to design cybersecurity solutions. And it's based on 5 things, which is to identify. This is where we identify the problem. Protect. This is where we put the outline to safeguard the facility and deliver the critical infrastructure services, and limit or contain the impact of potential cybersecurity events. Then we go to detect, which to detect and discover the incidents. Then to respond, which is a very important part, to take an immediate action regarding that incident, and then to recover. I just wanted to say that this is one of the methods that we work, but this method is also based on a bigger framework, an original framework that is called the OODA loop. If you could, yes. So the OODA loop is actually a method that's been done by Major John I've got John. He's in the U.S. Navy SEAL, and he's a genius. He built this framework for any security. It was not just for AI. It's for any security response that affects cybersecurity or security. So it starts with the reason why it's called OODA is it's because it says observe, orient, decide, and then act, which taking an action. Now I'm going to take you all through what every one of them means. So going next to the next slide, please. Yeah. So observe is based on an environment and an event. So if you could just Bashir can click the yes. So the thing is about it is that we observe and we understand, as we said, the environment for threats, risk, exploits, and vulnerabilities. For that matter, that's how we observe. Now, as I said, the OODA is a loop, and it's like loops inside the biggest loop. So what we observe and the events that we collect, once we have that, we go to the orient, and the lessons, as you see the arrows coming back, the lessons that we learn from the observation. No, it's okay. No, it's fine. I mean, I'm just talking about the arrows. That when what we learn from orient is going back to the what we learn from observe, we go to the orient. Now, when the orientation, as you said, requires two things: experience and knowledge. Now, experience is very important because everything we learn, every incident that we have passed through, gives us a lot of input that we might use in the future. That is all also in knowledge, that we can combine knowledge, and it's just knowledge is not just in security, knowledge in anything in regarding an incident, like technical knowledge, or I don't know, investigation knowledge, or even if we have an incident somewhere in because I say this is not just about security. So if you have a crime, everything in the crime scene is also a part of knowledge, and experts from every part comes in. So this is the importance of knowledge. After that, we go to decide. If you can just share, if you can just click on for that matter. Yes. So the decisions are made of the companies, as we say, hypothesis and creativity. We create a hypothesis for that matter, because we don't know all the information at the thing. If it's at a new incident, so we create a hypothesis. We just create an assumption what might have happened here, and then this is where the human creativity comes in as well, to analyze and say, okay, then if we have missing information because we don't know, then we have to recreate those incidents with our imagination and see what happened. And this is a critical element in the modeling, because that's what makes us have a decision. And after we have decided, then we go into the action, which is the last thing. The action, of course, will take to be alongside the actual expected impact, which is the mitigation. We act and we mitigate. Actually, this is where the threat model can be understand the risk versus the cost. This is a very important thing, because we need to know, we need to take an action, but we also need to see the cost of that. And it's not just here. We're not talking about monetized cost. It's also the cost on business, the cost on people, the cost on anything. And at the end, the results of all of that, if you can just click on the thing, as you can see, everything here from those ones will be lessons learned, and we loop into those ones inside. So the OODA loop is a big loop, but every stage in it is a smaller loop, from observe to orient, orient to decide, and then go back, decide to act, and we go. And sometimes, even after we pass through the whole thing, we cannot solve the issue. We have to go to another loop, but everything we learned from the previous loop, we also apply it to the next loop. So going forward from here, I'm going to talk in this part about the machines that fight, which I mean by that, it's like a fancy name for how computers with machine learning can fight for cybersecurity. So let's go and see what's applied machine learning for cybersecurity does. So it's used in insider threat to classify, predict, and represent bad users within an organization. It's very important. As we know, most of the incidents are created by internal users, not external users, right? Next thing we have to do is also to that it helps us that machine learning helps us in is malware analysis. It classifies malicious software, distinguish them from the useful software. You know, that's the thing that humans would take a lot of time trying and understanding. Machine learning can help that. And another thing that it could help us with is also network analysis, like classify, predict network intrusions, network traffic analysis, penetrating like also phishing IP addresses or anything like that. Everything that happens on the network, it could be done. Another thing that machine learning helping us is also secure coding. There's a lot of talks nowadays about DevOps and managing your code from a developer to another. But when a huge team work on a bigger solution, one of the challenges is also the security of the code, which cannot be inherited from a team to another. Some of those teams work in different countries, in different cultures, and in a lot of knowledges, and many of them do not know anything about cybersecurity. They're just developers. So this is how it could help us with it. And the last thing that we're going to talk about here is like a situational awareness. That's incident and response. It's like such as alerting security officials or officers quickly when something has happened. I just wanted to tell that I worked a lot on mass surveillance and, all the cameras in the roads, for example, that detects an accident, a crime or something. And the AI was detecting all of these things, but it didn't know, because it's not a human being, that is this an act of a crime or it's just an accident or whatever. It just had to go and tell someone, an officer, and telling them, this is what I detected. This is the video shot for it. You have to decide if there's an action or what kind of an action that you have to it. And this is the same in cybersecurity. When you receive, for example, an email that you don't know if it's a spam or not, and AI couldn't decide, it might alert someone and tell them, decide, is this email is a spam? And I've seen something nice in Gmail that they've been seeing for a while, that even the things that you subscribe, if you did not read emails from newsletters that you don't subscribe, they would tell you, you haven't read anything from that, from this email. Do you want to unsubscribe? So they would have suggested that might be a spam because you're not reading it. So you might recognize it as a spam and go. So this is some of major applied machine learning for cybersecurity. So going forward, we're going to talk much deep about the aspect for machine learning, and it's very similar. We have something called classification. That's example of ability to recognize a legitimate email to the spam, and the other aspect of that is what we call forecasting. As I told you, forecast, for example, the number of intrusions ahead by entering various patterns and all. It's how machine learning mimics human behavior and think about what is this, what was not there, and predict what's bad and what is not. So these are the main aspects that machine learning helps us into this one. So how does machine learning work? There are a lot of things that a lot of models that we say, but I'm going to concentrate today on these types of neural networks. Something called artificial neural network, or ANN. This is where you give the artificial intelligence network an input, you let it think about it, and it gets me one output. Like, for example, is this a photo of a cat or a dog? Is this a photo of, I don't know, Bill Gates or Leonardo DiCaprio? Or in cybersecurity, is this email looks like a spam or not? That is very simple. And you give them all the factors and do all of that. Now, the other thing here, the other model for that, which is a much complicated one, are the convolutional neural networks. If Bashir, yeah. So the convolutional neural networks is a bigger one. It's like we give not just one factor, but a lot of factors, and then we get an output. This is what's used, for example, in the security field in facial recognitions, or in cybersecurity when we use to decide if this device is compromised or not. We have a lot of factors in and out, and they interact with each other, and these interactions might create a vulnerability or not to this device. This is where we use something like convolutional neural networks. So going forward, another example of Bayesian neural networks is the Bayesian networks. Actually, this is more also used for also threat detection, and it's not just. It's a very complicated. You see, like in the case of is my device compromised, this might help us not just to detect what is happening on the device, but also what's going around. Is it coming from your network? Is it coming from a phishing IP address? Is it something from a software that is installed on your device, a software that is installed on the network? And here's an example that I'd like to give is that, for example, in this example, they say like you work at outside and you have an alarm, and your alarm only works if there's a burglary or if there's an earthquake, and you have two neighbors, John and Mary. John calls you. John is a very interesting guy. He's a very attentive one, and he calls you whenever he hears something. But sometimes, because he's very sensitive, he calls you sometimes when the alarm is there, or he calls you when he hears a phone coming from your apartment. So there's a lot of chances that his calls are not real because it's just a phone. Mary calls you when she hears as well, but she usually puts a lot of loud music in her house, and she might not listen or might not hear the alarm. And this is the dilemma: is that how many bogus calls you get from John because he just heard the phone, or how many alarms that Mary actually missed. This is how a Bayesian network works with complicated type of options, and see if your house is really compromised or not. So going forward, this is, as you can see, these are the possibilities in this, and this is the numeral algorithm behind that. I know this is very scary. I'm just letting you know that this is the complication behind it. So this is a huge function and formulas, and this is how we create the algorithms for the Bayesian networks. Okay, so I think we scared you enough for that. So let's talk about how does machine learning work. So machine learning have multiple ways of implementation. So one of them is supervised machine learning. This is direct learning. We tell the machine, we give it all the data that it needs, and we give it a lot of sample, and we label those samples manually before we give them, like giving them a lot of pictures of dogs, a lot of pictures of cats, and then teach them that, and then give them a picture of a dog or a cat that was not in the sample, and tell them, decide based on what you know about dogs and cats, if this photo is a dog or a cat. And this goes same for threats. So we could feed them a lot of types of threats and safe actions, and then give them an action and tell them, is that safe or unsafe based on what the information that we give you. Now, the other method of doing that is unsupervised machine learning. This do not involve us giving them the data, but we tell them where they can pull the data, and they can decide. Now, the first one might be really accurate because we are labeling this. This one might, because it's unlabeled data, and we're letting those machines decide. Some people say that it might be dangerous because they might not really know what's going on. So we have another method as well, not just three ones. It's called semi-supervised machine learning. It's between machine learning and not. So we give data and we tell them learn data, and if you are suspicious about something, tell us and we'll label this data for you. Now, the last thing that we're going to talk about here with this thing is that reinforcement machine learning. That now there's another one that's just so deep reinforcement, but it's kind of like a baby, and it's not real. But the thing is about reinforcement, it's a self-sustain. It learns by itself. It mimics human being, and it just improves itself by time. It's just like a human being. So these are the 4 things that we have. I just want to tell the last thing that about 70% of the AI applications are supervised machine learning applications. Now, in cybersecurity, we would need them all. So to us, we have to use all of those. Now, major machine learning uses, in the supervised learning, we have malware classification, we have spam identification, MLSec project on firewall data to predict score malicious sources like IPs or IP addresses. On unsupervised learning, we have DNS analytics. We have threat intelligence, feed curation, like IOC prioritization, deduplication, whatever. And we have tier 1 analyst automation. This thing in one study have reduced the workload from 600 million raw events to 100 incidents. That's the load on human beings. It's phenomenal. And we have user and entity behavior analytics. Because as you know, a lot of hacks nowadays do not just implant and attack. They implant a malware or a spyware, and they start collecting data and logging, stealing user information, logging, and sometimes they don't even attack. They just log in, steal information, and sell them somewhere. So, but this is very important, because normal users have normal behaviors, and when a hacker comes and changes that behavior, we should know, the machines should know, and they say, like, we're gonna block this account because it behaves very unusually, until someone tells us, like, this is the user who actually has done this action. He logged in at 10 p.m. while this is not his normal behavior. So these are for machine learning. So again, going forward, deep learning advantages is that it's automated feature extraction. It's very high detection on accuracy. Now, the issues with deep learning is that it needs a lot of data. Few records cannot indicate good from bad, so we have to have a lot of data. We have to collect a lot of it. Not much enough information with flows. How can I say that? I want to make it as simple as possible. The basic idea here is you have to provide a lot of data. If you don't have enough data, just don't do it, because you will not have context for them to decide on what is good and what is bad. And here we also have labels are not available, because we're leaving the machines to put labels on things. Okay, so going forward, AI advantages in cybersecurity. We have that, and these are, by the way, applied solutions that we have in the market, whether they are to sell or they are developed specifically or tailor solutions. We have spam filter applications, or we call spam assassins, network intrusion detection and prevention, fraud detection. A lot of banks and insurance companies do not have the time or the human resources to follow up on frauds and scams, specifically on credit cards or insurance scam. So they have these systems in place that detects those kind of weird actions and tells them. Credit scoring, botnet detection. I don't know if you know what botnets are, but they're like chat bots. They are like hack bots. They are like password bots. There's a lot of them. They would detect all of these kinds of bots. We have secure user authentication, cybersecurity ratings, and we have hacking incident forecasting. That's telling us what the future hacks might happen and when and how. Okay, so when we talk about the dark web, we're talking about the Black Widow, right? And here I'm going to talk about how AI is battling with the dark web. Now, the dark web is very known that it's a very dark place, and there's a lot of content there. But here's what I wanted to let you to know: 40% of the content of the dark web is legal, personal sites or groups. There are places for activism or for private legal sell and buy. It's legal, but it's just on the dark web because it's for a specific group. Now, the other 60% of those is illegal. Stolen user data, credit card information, social security, insurance numbers, pedophilia sites, cyber terrorism, etc. I mean, I'm sure that everybody has heard, like last year, about the information that was stolen from Life Labs here in Canada, 15 million user data with all their medical records has been stolen, and there was suspicious that were being sold partially or fully on the dark web. So these are the dark webs. Now there is, going forward, there's a study says that in 2019 that says that the listings, the harmful listings on the dark web has risen by 20% compared to 2016. There's also that part of this reason is for corporate espionage. So let's have a look now on how AI is actually fighting on the dark web. Now, first of all, it scans the dark web content to check if your business is a target for a bad action. So those hackers are talking about these things. They might use a lot of coding or anything like that, but at a lot of points they will mention your business or your company or whatever, and this is when the machines can detect those texts and tell you that somebody is planning something on you. AI applications also try to find and catch pedophiles on the dark web. There are also solutions to check if your credentials were compromised and shared on the dark web, your password, your SIN numbers, whatever. And there are solutions to check phishing domains before they even attack. And you know that we're not talking about not just phishing, but there are spear phishing who targeted your individuals or targeted specific businesses. And of course, whaling. So there are also solutions to check on personal and financial data stored on the dark web, credit card numbers, SIN, SSNs, bank details, a lot of them. So you can provide those solutions. You can provide your information, and they would, or part of your information, and they would tell you that these information are there on the dark web, and these are the sources where you can find them, and also detect malware behavior patterns and block them. So you know, there's a lot of things, but I'm going to give you some examples about that. So this is an article that says about hackers leaked password for more than 500,000 servers, routers, and IoT devices, and they shared them on the dark web. And there was an AI who detected these things and started to notify users or the people who have their data stolen. The other example here is this is in Arabic, and this was a site that was created by ISIS, you know, the terrorist organization. It's in Arabic. It looks like it's a tourism site, but it was giving information, hidden information about places in the world that are like very busy, and to make it easy for terrorist attack, that if you're planning to do a terror attack and you want to target a lot of people, so these are the places that you're going to look like. It looks like a tourist website, but it's actually for that kind of purposes. So going forward, I'm going to go you a showcase for that matter, and this is actually profiling cyber criminals using natural language processing, or NLP. Now, natural language processing, I just want to give you a series, is like reading the text or writing a text just like a human being. It mimics human being to read and write. And this solution is done by MIT. It's very nice and very important, I believe, going forward in this thing, because you know, if you get these hackers or the text about them like planning something, many of those hackers, they don't use one forum or they don't use one screen name. So they use multiple forums, they go in multiple places, they use multiple screen names, and connecting these things together is very difficult. You don't know that this is the same person who's posting here and there. Now, this solution actually analyzes the text, the style of the writing, the style of punctuation and all, and it says that these persons on these forums with different screen names, different forums, are probably the same person because they are using the same style of writing. This is like a treasure for cybersecurity forces, because they could easily now find the connection between those screen names, those forums, and they realize that this is the same cyber criminal who's doing all of this, because this is his or her style of writing on all of these things. There's a link here, and you can find that. This is just a showcase. The screen that you're seeing, it's one of the softwares that we have seen a demo. As you can see, it just shows you the threat, what type of the threat it is, the IP address that coming from, how many the alerts. It alerts you. That's for your business. So if you're monitoring what people are talking or what people are planning on for your business, you can have softwares like that, and they will collect things on the dark web and alerts you to do that. Okay, so this is very important to talk about. Also, I'm not just concentrating on too much, but it's important to understand that there are biases in AI usually. In any application in AI, but I'm going to concentrate on that happens on cybersecurity. So, common data science ethical issues in general, fairness or discrimination, ownership, transparency. We have privacy and accountability. We have anonymity, confidentiality, identity, and reputation. And I highlighted privacy and accountability because these are now the highest risks and the most related to cybersecurity. When did my data was stored? Where is it stored? How was it stored? Was it secured? And if something happened, who's accountable for that thing? Is it the place that you're hosting? Is it the people who actually designed the solution? Is it the algorithm? So there are a lot of things. The cause of biases, of course, kind of like design. How do you design the solution to solve the algorithm? How do you write the algorithm? Also, the data exploration. Where does the data come from? And is it clean? Is it right? Is it trusted? Is it complete? Or is it, is it just the data that we collected and we don't have a missing? Is it covering every aspect of the incident? We also have data processing. Has the data been cleaned, unchecked, and ready for use? That after I collected it, did I do my job and cleaned it and make it ready for my application? And prototyping. How will the developed model work? Should it be pivoted as well? It's also about testing and testing and testing. Also, there's production. Can we harden and scale the model? Of course, I think when I say harden, also I'm saying from a data structure point of view and from the security point of view. Also maintenance. What is happening to the data? How to update it? Because we can't just put the data and rely on it for a year to come, or even for weeks to come. Somebody has to maintain that and improve it. Okay, now how does that happen? How does bias happen? As I always say, machines are not biased, humans are. So human biases always affect. Like there was an example that there were in some software for predictive policing. There were two cases of one white male and one black lady. The white male has a lot of incidents and crime, and he has some criminal records. And the girl have like some juvenile kind of thing. She's a young girl, but she's black, and the system showed that the black girl poses a bigger threat than the white guy who have a bigger criminal record. And the thing about that is the bias in data, the bias in how the data was provided. And of course, the machine doesn't see black and white, but it's the data that we put in and how we process the data. So this is one of the reasons. Also, the social and political climate. We all know that politicians change things from time to time, and that might affect that things. Now, the variance trade-off is also one of the central problem is in supervised learning. This is one thing that we have to look at, because we always have what we call them like the outliers. the things that do not follow the rule or anything in any study, in anything. So these are what we call bias variance trade-offs. If we go going forward, I'm going to show you maybe visually it's going to be easier than putting all this text. So if you go forward to the next slide. So these are the biases forward. So the first one, if you see the on the scales, we have the underfitting, which is we just put like a straight line, and we collect as much positive cases and sometimes negative ones. But in that we have to trade off. In this case, like we've traded off like 2 cases. The other one is good compromise, where we create something a little bit curvy, an algorithm that collects much and tries to avoid as much as we can negative cases. And there's overfitting, which has had a high variance. Now this is the most difficult, and this needs a lot of maintenance for that matter, but it's possible. And the other one here, we could talk about low. This shows us how high bias and low bias, with how variance and low variance can work. So if you have high bias and low variance, you can see that you put them all in one space. If you have low bias and low variance, you get into the target much better. And other cases are depend on how we develop our bias algorithms. Okay, so the fears of AI biases in cybersecurity. So incomplete or wrong data might cause wrong predictions. That is, some people, in other words, some people might get in trouble for doing stupid things. A malicious actor, including nation states, or rogue states, or nations that we don't like or they don't like us, they are using AI to undermine the cybersecurity of other nations and foreign businesses. We have examples of that, of course. Most sophisticated defense against cyber attacks, the kind of defense employed by large corporation and nation state that protects vital systems and infrastructure. We have also machine learning could be used to create poison well scenarios. The ones who are in the cybersecurity knows what a poisoned well is. And the AI process is like a black box. Like, we don't know how those machines actually make their decisions. But there's a lot of talk now about AI explainability. It's not very done well, but it's progressing. So we will tell the machine, give us a decision and tell us why have you decided. It's just like a human being. Tell us what was your decision and why your decision was like that. And also, we have to remember that humans are still in control and humans are biased in nature. So even if you get a prediction from a machine, your human biases would still apply, which is actually the solution mostly is to train those humans to be less biased, to give them more cultural exposure. And we have the adversarial attacks that are significantly easy for people to play with that. In the next slide, actually, I'm going to show you exactly how an adversarial attack could happen and how easy the experts in this field can manipulate it. So this is a photo of a panda. The machine expected that this is a panda because it's a small and there's a cut, it's not fully phased. It detected that it's a panda with 57.7 confidence. Now, here is this garbage thing. This is noise. And when we ask the machine to detect it, it detects that it's a nematode, which is a kind of a worm, by 8.2 confidence because it didn't know what this noise is. But when we applied this noise to that image by 0.007x, okay, this was the result. If you look at the third image, it's actually, to the human eye, nothing. But to the machine, it detected them as a gibbon by 99.3 confidence. And if you look at the next step, this is actually how a gibbon looks like. It's nothing like the panda, but this the thing in the middle, this noise in the middle, have fooled the machine to think that this panda looks like this gibbon. There's nothing. So this is only for you to visualize how easy it is for an expert who knows how these algorithms are designed to actually, make an adversarial attack, to fool a machine, in other words. So this is one of the things that we talk about it. And that's just a quick slide. If you're interested in ethical AI, I'm just writing an upcoming paper. It was supposed to be this month, but whatever. And I also have another talk about ethical AI that is published on YouTube, for that matter. If we can just go forward, Bashir. Yes, just go forward from this slide. It's just an informational slide. Okay, the last topic we're going to talk about is AI vs humans. And here's the thing. I've been to, Bashir knows that we've been into a lot of cybersecurity events and all. And people in cybersecurity, just like everybody else, are afraid that if we implemented AI, then our jobs are going to be lost, which is actually not really true. But this is the human nature, because machines are taking our jobs or taking tasks of our jobs all the time. So going forward, I just want to tell people that that first of all, we didn't have a general intelligence. We don't have an AI that solves everything like a human being, and we cannot match a human being by any existing machine. People, when it talks about security as well, it's not just about data. It's also about the human factor. We have compassion. We have perspective. We have genuinity and honesty that doesn't exist in the machines, and I don't think it's going to be there for a long time. The thing about us now, why do we need to use this, is we also have limited memory and limited amount of energy to operate efficiently. So those machines can work 24/7. They would not complain. They would not, and they don't have a limit for memory. As much as you put memory and hard drives or processings or processors or whatever, they would work. It's not like a human being with a limitation. One of the things that also works against us is that we are emotional. Sorry, if you could just go back to the previous slide.
Yeah, I'll edit that out.
It's okay, no problem. We're emotional and biased and forgetful as well. So we need machines for us to remind us and to eliminate our biases. Learning cycles start from scratch. So every generation has to learn by itself. They could use the information from the previous generation, but they still have to learn on their own. That doesn't happen with machines, because we can transfer the data in a blink of an eye from a machine to another. Humans can work in groups as well. But this is one of the things that we have, is that we can also, like, there's an example of an AI that was playing games in groups, like I think it was Warcraft. And the AI was making a lot of progress, because it was fast and it was doing but when a lot of humans didn't know that it was an AI, while they were playing. But when a lot of humans realized that this player is very advanced, they did like what they do. They all collaborated to kick that player out. And even though the AI was very fast and very efficient, because a lot of people in groups, conspired against it, it was just defeated. So this is one thing that machines cannot do, is the teamwork and the group works. This is something only human. So going forward, that's when we talk about machines. They are very obedient. They do exactly what we tell them, when we tell them, and how we tell them. They don't forget. They don't have to start from zero. Every time we can migrate the data, we can update it from a machine to another. It doesn't matter. Biases are inherited from humans, so they don't have actually biases. So if we give them less biased data or non-biased data, they won't give us biased results. And they are non-emotional, uncompassionate, very logical, and have no ability to lie or compliment. That could be a good and bad, because they might not have the human factor, but because they are not emotional, they give us a more logical decision. They are unable to make final determination. That is a very important thing. In cybersecurity, I always tell people, Those machines are not designed to decide for people. They're designed to give you predictions or recommendations. The final decision should always be for a human being. So machines are also faster and could be more accurate handling large amount of data. We know that our brains are very limited, but those guys can process a lot of data. So going forward from here, I believe we're at, creating solutions to fight attacks is much easier than similar. Yeah, so there are some things in the market. There are some attackers that try to create AI to act like a hacker. It's, the problem about that is that it's the learning. The thing about hacking and security is not just about learning a machine how to hack. It's very complicated. There's a lot of creativity, and those machines are unable to be that creative. So we're still on the top. So the final word for that is that machines are not designed to make decisions. We are the ones who create them. We create them to help us and to do that. But going forward from now, when these machines are becoming more intellectual and more, I think we have to work together for a better world. And this is a quote that I've heard from one conference. I said, there's no match for human ingenuity and empathy. So I just wanted to say that the more we imply AI into cybersecurity, the more we need people into cybersecurity, because they help us do some iterative jobs, iterative works that give a lot of space and time for cybersecurity experts to be more creative, to think forward, to create better solutions for the future, and leave those iterative jobs like detecting malware or detecting phishing IPs to the machines, and leave it a lot to the cybersecurity. And I would push everyone in the cybersecurity field, don't be afraid of AI, go forward with it, learn how to do it, and there's going to be a lot of job for everyone. So Bashir, thank you very much for this, and thank you very much also for doing.
Thank you very much, Hisham, for a very interesting and a somewhat thought-provoking session. As you told us exactly as we were hoping to, as to how artificial intelligence can play an important role in cybersecurity in terms of catching, but if not handled correctly and the biases that you talked about, it can also produce wrong results. So there's still a lot of work to be done, but for some part it can be used quite successfully. And I want to thank you very much for the presentation you did tonight. And to all of you out there who were watching this, please remember that Hisham will be available to answer your questions as we move forward. And if you send us an email at events or info@btpac.org, in fact, you can send to any of them. We've even given you Hisham's email. But we'll bring him back here. Thanks very much. Have a wonderful evening.